Afternoon. So I'm going to talk about databases in testing and why they're slow and rubbish. I hasten to add, this is not my artwork. I'm not a budding Zed Shaw, and you have one of my designers at work to thank for this. But it's quite impressive. So, okay, so newsflash, your database is slow. Well, I don't care what database you're using, it's slow. Postgres, MySQL, well, MySQL is definitely slow. SQLite, anything. And the reason it's slow is because you're trying to do testing, and you want your test to be as fast as possible. So when you're doing things like writing to disk and interfacing over a connection and even just translating your Django objects all the way down into some SQL statement and getting a text string back and turning them back into Python objects again so that you can do things, it's slow. And you're probably wondering why on earth you care. Well, we want things to be fast. And the reason we want things to be fast is because the faster your tests go, the more tests your team's likely to write, the more times they're going to run it, the more time that they're more likely to get on with it, and nobody likes hanging around. And there's nothing more frustrating than making a one-line code change and having to wait 3 minutes for your Android emulator to be built, sorry, for your tests to run, because you want to iterate quickly, and it interrupts your development flow, and what I've found is it's one of the tests running slowly is one of the biggest barriers to people getting involved with contributing to your project, or even just actually bothering to write the test for their own features inside your team, because they get bored waiting for them. So what I'm going to do is talk through some ways that we can avoid hitting the database in tests using an example, and then once we've talked about how these work and why they all suck, we can have a look at some alternative ways of doing things. So let's suppose that we're going to build a Spotify clone or an RDO clone or music player of your choice. And so we've got a fairly simplified data model that's got artists and tracks and record labels and albums and so on. And then we've written this method that's going to get called by our API, which sort of serializes a track object into a bunch of information. So these are all like strings that we get out, and hopefully you'll notice somewhere down the bottom here it's got a many-to-many field between the artist and the tracks that's called collaborators, and you've got some foreign keys going on and some if statements, and this is obviously a very simple example of a piece of code that you might want to write some unit tests for, and you want to plug in a whole load of different options and check that all the logic works and that you get the right answer out the end. So let's suppose that we're a newbie programmer, or new to testing, and we're going to write this test really naively. So we're going to create a label object and create an artist and create an album, and then we'll create a track and we'll create another artist and add that artist as a collaborator, and then we'll do an assert. And this is simple code, and it does the job, and it does run some tests, and great. And then we can copy and paste all this code and do 2 or 3 different versions of it immediately afterwards. And this is fine. And it runs 8 database queries against your database. And so, full disclaimer of benchmarks, they're run on this laptop. They've not been run a million times to see how consistent they are, but they should hopefully give you a decent indication. So, obviously, I deploy my websites onto Postgres wherever possible, and running this test 1,000 times through on my laptop takes about 5.2 seconds. And then I go, oh, so if I've got 1,000 tests like this, it's going to take about 5 seconds, and for testing a small amount of my code base, that's quite a long time. So I look around on the internet and I say, so you can change the database to make it SQLite in memory, and that'll make it faster. Yep. Okay, so we're now at 3.9 seconds. That's progress. We're better than we were. And this, for most people, seems to be the default answer for what they do when they're running tests. So I didn't really like that code very much. It was a bit trivial, and there's going to be a lot of copying and pasting if I've got 20 or 30 different examples of this, or for that matter, if instead of having 4 models in my hierarchy, I've got 40 models in my hierarchy. So let's suppose instead that we're going to use the wonderful library called Factory Boy, and we're going to just create a track object. And by creating a track object, it creates everything else up the tree. But then we're going to need to create another artist and add it as a collaborator, and you could do that inside your factory, and then that would work as well, but you're hiding the code there anyway. And this works fine, and you then can check the details, and this test is half the length of the previous test. So less lines of code, less duplication, less stuff to change if you add a new field to one of your models. So this is great. And this does 8 database queries. And it's now 5.9 seconds on Postgres, so it's got slower. And the reason it's got slower is because Factory Boy's got a whole load of crazy function calls going on to build all these objects, and function overhead costs time. And we run it on SQLite, and it's 4.4, and now our graph looks like this. So we've kind of got 4 options, and there's not a huge amount of difference between them. We may as well choose any one of those because, 10% speed up or whatever, 15% speed up. It's good, and it saves a bit of time, but it's not that dramatic. So Factory Boy comes with this really awesome thing called factory.build, which will build you a instance of the model with all of those attributes as normal, as if you'd instantiated your model class, but you then hadn't called save on it. And that means that thing doesn't have to go and hit the database. But we've got many-to-many fields here, and many-to-many fields tend to shout. So we'll build something, and then we'll add a primary key to it, because if it doesn't have a primary key, then I can't access the collaborator's many-to-many field at all. And then we'll have to create the other object, and I can add that to it, and then the assert works, and somehow we've done 4 database queries, and we've got a row in the many-to-many table, and yeah. I'm not quite sure why this works at all. I haven't benchmarked it because it's ugly, and don't do that. If you're going to do builds or creates, do one or the other, not halfway in between. So I was thinking, if I want to access all, and if I wanted to make that fast in a view, then what I do after Django 1.4 is do a prefetch related to get that off all the objects. So let's have a play around in the prefetch related code. And so we'll build a track factory, and then we'll give it a primary key so that we can mess with the many-to-many field. And then we'll build another artist. And then we'll say that this object here is collaborators.all, which has just given me a query set. And then I can fill the result cache of that query set with my other object. And then I can set the prefetch objects cache on the track. And then I can do my assert, and it works. And now I've got no database queries. Hooray! And the code's a bit gnarly, but we've now got 1 second. So we're about 4 times faster than we were a minute ago, even running on SQLite with the naive tests that was the quickest one. Problem with doing this is at the moment, until we get more complicated prefetch related, we can't do this at all if we're not using all. So if we were doing get me all the collaborators, excluding the current artist or whatever, it would just fall over altogether. And our graph now looks like this. And this is much, much nicer, because we're a huge amount faster than we were before. So that's one way. And the other way we kind of play around in tests to make things work the way we want them to work is we use mock. Mock's a wonderful library. I hope you all use mock. Not saying this is necessarily a good use case for it. So the problem that we've got is many-to-many fields are a descriptor. So we need to create the mock, and then we need to set it all, and this mock's going to be the many-to-many object. But because it's a descriptor, the many-to-many field, we have to, if you read the mock docs, it says patch the class before you instantiate the instance, because you can't do it the other way around. So we have to patch the track class, and then inside that we can then build the factory, and we have to know where we're building our track object so that we can patch it in the right place. And then we can assign the primary key so that we can then access the many-to-many field afterwards, even though we're not actually hitting the database. And then we can assert that the details that we've got are what we want them to be. And this is still no database queries, so this is good progress. It's slightly slower, and it's definitely powerful. I mean, this we could do because we've got a mock object. We can do filters or excludes or any other crazy things we might possibly want to do on our related query set, and it'll do the job. And we end up with a graph that looks like this. So that's not bad. We're doing quite well. I'm not a big fan of either of these approaches. They work, and we can say that avoiding the database is significantly faster, about 4 times faster than not hitting the database. And it's actually quite a substantially bigger difference than the difference between SQLite and Postgres. So running on Postgres that's running primarily in the RAM on my laptop is actually quite quick, even compared to running your entire SQLite memory and database. And there's an argument to doing this anyway, so you write your code in such a way that it makes avoiding the database easier. So you try not to do queries in functions that don't need to have queries. So if you want, like, this was an example in that, like, I could have modified the original method so that if I happened to know the collaborators list beforehand, I could pass it in as an argument, and then if it wasn't there, I could load it. I could load it in using the queries, so that would allow me to test it differently. And this is quite good. But it got me wondering, is there a better way? So a lot of my inspiration for how I write tests comes from a wonderful talk by Carl Meyer a couple of years ago at DjangoCon US, I believe, who sort of went through a whole load of best practices for unit tests, and it really explained well the differences between unit tests and functional tests and integration tests, and what you should use for what application, and fixtures are bad for unit tests, and Factory Boy's great, and don't touch the database because it's slow. And somewhere in the middle of that talk was this comment: mocking the database usually isn't worth it. And I kind of accepted that for a couple of years, and then I was doing some work with a project where I was using Redis quite a lot. And I was thinking, oh, spinning up a new database in Redis is semi-complicated, and Django doesn't have a framework for doing it for us, and Django Redis doesn't really have a framework for doing it for us, so I was going to have to work out how to create a new database for the test and tear it down in the right place and make sure that was all set up. I was Googling around for it, and so there's an implementation that was originally done by Mozilla, I think, that's lurking in some of their code base. It's not particularly well packaged, but it's just one file, so it's there. And that basically re-implements the API of Redis in a Python, basically a Python dictionary. So it stores everything inside this dictionary, and you can call it. And it's incredibly fast. And you don't have to have Redis installed in your system. You don't even have to have the right headers installed or anything to install PyRedis, which is great. So like their use case for it originally was, well, we've got like 1% of this site that actually uses Redis. And so, yeah, when we deploy it after our CI box, we want that to test, but we don't want all of our developers who are working on the other 99% of the site to have it. And that seemed to work really well. And part of the reason it works really well is Redis has got a nice, clean, well-defined API, and managers and query sets are a nice, clean, well-defined API. Well, mostly. So I thought we'd give it a go. So this is Django TestDB. Catchier name suggestions are invited. It's probably not the best name in the world, but someone had already taken Circus, so I couldn't have that one. So what is TestDB? Well, it's not really a database at all, if I'm honest. I'm not quite sure that I've got the right name. So what it does is it sort of patches query set to, or mostly query set, to provide you with the same API as you're used to seeing, but it just dumps these objects into memory somewhere. And then when you go, get me this object by ID, which really is quite a simple piece of functionality to program in one loop in Python, and it works, and it gets you back the right object, but it doesn't hit the database. And the more I thought about this, I thought this would be a really good concept, because you can run your local tests like this, and they just run database-like or querying code, and they're really quick, hopefully. And then when you deploy it to your CI server, you just turn all this funny patching off and run it against the real database, because it doesn't matter so much if it runs slower on your CI server, because you run it once per pull request, not 300 times per pull request. So I'm jumping on the prototype bandwagon. This is a prototype. It is not production-ready code. Don't try and pip install it and install it on your software straight away. It has a small subset that works. But it's got enough that works to do our demonstration. So here we've got TestDB, catchily named, which is, you'll hopefully recognize this code. This is the naive test we had earlier. It's really simple. You haven't changed anything about how you're writing the code, how you're writing the tests, or anything. And we get no database queries. And it's 0.7 seconds, which is faster than anything we've had before. And it's exactly the same code. So this is great. I'm slightly cheating, because at the moment, this lovely collection of mocks is necessary to decorate the test case with to make it all work. So there's still some work to be done. In particular, there are certain operations like a new instance.save that don't go through the query set at all. So it would be nice to do some auto patching so that you can point it to a file and go, yeah, just patch all the models in that file, and then I can run my code and it'll work. I've done some of the filter lookups, like the _exact and contains and iContains and so on, but they don't all work. Roughly speaking, like ordering works, many-to-many fields work, foreign keys work, reverse foreign keys work, some of the simple operations, and they're all implemented in not a huge amount of code. I mean, doing an order is a sorted call in Python, so you may get some odd things that don't necessarily work how you'd expect them to if you're relying on clever features of your database. And obviously, an implementation like this is never going to work for custom SQL, because I don't understand custom SQL, I'm a Python script. So, and also it could do with a bit more extensibility for how you would plug in sort of extra bits of functionality. So in the future, probably needs partially rewriting. My ideal is that you can write your code and your tests naively. You can write in the way that you think and the way that you just want to operate on your objects, and it's fast. You don't have to worry about performance. You just do it. And then you can use this locally, run your tests really, really quick. And it's not going to check for integrity errors or all these sorts of things that you actually care about, but then you deploy it off to your CI server and you set some environment variable or change a setting and it turns it all off. And because it's turned it all off, it runs it against Postgres or your deployment poison of choice, and you find out whether the code really works. And of course, you can set that environment variable once or twice to run it locally. So help would be great if people think this is a good idea. It is up on GitHub now. So I put in a bunch of issues. I'm hoping to do some work on it at the sprints if I get the time. So if people think this is something that they'd like to see and they'd like to get working, I've mentioned it to one or two people in the course of this week, and they sort of agreed with Carl that for one person to implement this, it's not worth it for an individual project. But if we implement this together and make something that actually works for 90% of use cases, and it is 7 times faster than running your tests otherwise, it will hopefully reduce our collective frustration level while we're waiting for those dots to appear on the page. So thank you very much. Any questions?